Now let's talk about the 802.11 protocol family. So basically the 802.11 family consists of a half duplex and over the air modulation techniques. So what do we mean by half duplex? So it's basically, as shown in the figure, the communication is on both sides of the in both directions, but only one direction is active at a time. So either we can talk to or we can talk fro, but we can't talk to and fro at the same time. So that's the basic structure of 802.11. So let's look at some historical facts about 802.11. So it was originally made in 1997 and was clarified later on in 1999 by IEEE, but that particular version is totally obsolete, mainly because its maximum supported bandwidth was 2 Mbps, and 2 Mbps was too slow for most of the applications, and that's why it's totally obsolete now. And we use the other variants, the A, B, G, and N. So now after 802.11 came to be useless, the 802.11b came into existence. So 802.11b was the first improvement over the standard defined by the IEEE in 1999, the 802.11 standard, and now it could support up to 11 Mbps of bandwidth, which was a huge advantage over 2 Mbps. But 802.11b still used the same unregulated radio signaling frequency, that is the 2.4 gigahertz frequency, and it still had some interference problems, but if we keep it at a reasonable distance from other appliances, the interference could easily be avoided. Looking at its pros and cons, now as a pro, 802.11b had a very low cost, was cheap, and the signal range was very good, and it was not easily obstructed. But on the other side, its maximum speed was still pretty low, and home appliances may interfere on the unregulated frequency band. So that was still a problem. Moving on to the next one, 802.11a. So 802.11a was the second extension to the IEEE 1999 standard, and now this was particularly made to support the business networks, and this could support up to 54 Mbps of bandwidth, and that was huge. And now its frequency spectrum had also changed. It was regulated around 5 gigahertz, so now interference was not such a problem. But again, because of such a high frequency, it had some problem in penetrating the walls. Looking at its pros and cons now, on the positive side, it has a very high maximum speed, it has a regulated frequency which prevents it from interfering, but on the other side it is very costly, and that's why it's only meant for the business purposes, and it has a very short range, and because of the short range it can be easily obstructed. Moving on to the next one, 802.11g networks. So it came out in 2002 and 2003, and it attempted to combine the best of both A and B. So A had a maximum frequency bandwidth of 54 Mbps. So now G had a maximum frequency of 54 Mbps, but unlike A, it had a frequency range around 2.4 gigahertz, same as B. So it combined the best of A and B both. And now the best thing was it was backward compatible with 802.11b. Looking at the pros and cons of 802.11g, so on the positive side, it has a very high maximum speed, its signal range is excellent, and it's not easily obstructed. But on the other side, it is still more costly than 802.11b, and appliances may still interfere on unregulated single frequencies. Though it has the versatility of A and B both, still it had this particular problem existing. The next version which comes in this family was 802.11n. The work started in 2004, but it finally got ratified in September 2009. So broadly, the goal was to increase the data throughput, and a number of complex technical changes were applied in it. And one important change was multiple input, multiple output, that is MIMO, and spatial multiplexing. So these things The spatial multiplexing thing can't be explained in detail. That's beyond the scope of this course, but you can definitely look it up over the net. And so the multiple antennas were used in MIMO, and basically it used A, B, G, multiple radios, and therefore utilized more electric power for more throughput.